Hi there everyone and welcome back to Laties Lessons. Grade 9s, this is your part 2 for balancing chemical equations. And I got a few requests from some of you that you would actually like to know how you would go from a chemical word equation or a sentence written about what is happening to actually balancing the word equation. So what I'm going to do is I've got a couple of chemical word equations here and we are going to work them out. But first, it is very, very, very important, guys, that you understand that you need to really know how to look at your periodic table. You need to understand what are the differences between acids and bases. You need to understand which are metals, non-metals, and definitely it is very important. You need to go and learn the common names of the elements. So if you don't know what they are, you are definitely going to struggle further on with chemistry. So please go and study your chemicals. This is such a nice one. You can pause the video here if you want to start learning the common names. So they are all over here. But yeah, let's jump. Let me just put this one down somewhere. Let's jump into the video. I am going to try and see if I can get this video not too long. But the first one that I've written down for you guys is when you add an acid to a base, the reaction is called a neutralization reaction. Now you've learned about acids and bases and you know that everything goes according to the pH scale. So looking at the pH scale, your neutral is actually in the middle. So that's where water and substances like that are. Your acids are from 0 up until around 6 or so for your acids. And then when you go to your bases, that's when you go on and you get further on towards all of these alkalines and basically taking it up to the pH scale to 14. So 0 to 6, 7, 6, 7, you are getting to your acids. Neutral is at 7, all the way up towards your alkalines, 14. So now, getting back to your neutralization reaction, whenever you hear that word, you know, hey, one of my products is definitely going to be water. So let's have a look at our sentence here. Let's check it. It says when hydrochloric acid and sodium hydroxide combine, acid and a base, the products are sodium chloride, derived from hydrochloric chloride, and water. Now they're asking you, write a chemical equation that is balanced. Let's put that one to the side and we will break it down. So first of all, let's just have a look and see. First one we said was hydrochloric acid. I know hydrochloric acid is capital H, hydrogen chloride, hydrochloric acid. Then they say plus sodium hydroxide. Sodium is Na, hydroxide, oxide, hydroxide. Okay, you see where all of the elements come into play. Sodium hydroxide. Okay, gives me products are sodium chloride and water. So sodium chloride, again, I know what sodium is, Na. Chloride is just Cl plus water. In the previous video, I showed you how to balance chemical equations. Break it down. I've got hydrogen, I've got chloride, I've got sodium, I've got oxygen and hydrogen again. On that side, I should have hydrogen, yes. I should have a chloride, yes. I should have sodium, I do. And I have oxygen. Cool. How many do I have on each side? That is going to determine if this is a balanced chemical equation or not. So hydrogen on this side, I've got 1, I've got 2. Boom. On that side, I've got 2. Okay, hydrogen, we're lucky. On this side, chloride, I've got 1. Let's just make it a nice dark one. Okay, and then on that side, I've got chloride, I've got 1. Then on this side, sodium, I've got 1. And on that side, sodium, I've got 1. So far, everything looks balanced. Oxygen, on this side, I've got 1. That side, I've got 1. So, looking at this, our reaction is actually a balanced chemical reaction as it is. Hydrochloric acid plus sodium hydroxide gives me sodium chloride and water. Right, so we've learned when metals react with water, they form hydroxides, which are bases. The base sodium hydroxide, also called a caustic soda, is used in preparation of soap. Interesting little fact. Okay, that is our first little one that we are going to look at. I hope this makes sense. Nice and easy one. We've balanced it quite nice and well. No real issues with it. I am happy. Hope you guys are happy. Let's move on to the next one. Okay, so what do we have here? Whew, that looks like such a difficult one. Is it difficult though? First of all, when magnesium is burnt in air, the product that is formed is magnesium oxide. Okay, so I'm looking at magnesium. We know magnesium is Mg. Then it says air. Air is oxygen. Okay, then it says the product that is formed is magnesium oxide. Magnesium in air, Mg. What are we looking at here, guys? Magnesium in air. So basically, Mg plus O2, because air is oxygen, then we get magnesium oxide. So what are we going to have to do now? So first of all, we need to go and work out what on earth is going to be our products here, what are going to be our reactants that we are looking at. So first of all, what do you guys think we need to do? I think let's move away this thing here and go. Magnesium, I know it's Mg. Oops, my Coke here is no longer wanting to work with us. Hopefully this one is. Here we go. Mg plus oxygen. And I know if I take oxygen straight from the periodic table, I've learned that I have to make it O2 subscript because it cannot stay on its own. Our product is definitely going to be magnesium oxide. No longer needing the 2 because it is now bonded with the 1 magnesium. So let's balance this quickly. We've got magnesium on the one side, magnesium on the other side. We've got oxygen on the one side, oxygen on the other side. How many magnesiums do we have on this side? 1. How many magnesiums on that side for now? 1. How many oxygens on this side? 2. How many oxygens on that side? 1. I need to times this oxygen with 2. The whole thing, remember, times 2 times 2 to give me 2 to get it to be balanced. But do you see that we now have also timed the magnesium? So 2 times magnesium is 2. 2 times oxygen is 2. This side, we are done. On this side, oxygen is equal, but now magnesium is not. So we have 2 magnesiums plus O2 gives me 2 MgO. Okay, so we have gotten first a word equation. I haven't written that down yet, but magnesium plus oxygen gives me magnesium oxide. Oxide, you spell it like this. Oxide. I hope that makes sense. Right, that's the first one down. Let's wipe the board. Get this done and dusted. Oh-wee. And we will have to move on quickly to the next one. I don't want to make this video too long, guys. Let me just get to my notes on this side as well, because I'm trying to keep track of what we're talking about, and I want to check and see if I have the right notes in front of me. I think acids and bases again. Okay. Now, let's have a look at the last one. A student drips a drop of hydrochloric acid on a pile of white, powdery magnesium oxide pellets. A chemical reaction occurs and it leaves us with two products. The first is water and the second is a chloride. So, we are now dealing with the general reaction of an acid with a metal oxide. Okay. So, when magnesium oxide reacts with hydrochloric acid, our products are magnesium chloride, which is a salt, and water. So, let's first start by writing a word equation. Let's just do that. I'm going to say hydrochloric acid plus magnesium oxide gives me magnesium chloride, there's our salt, and water. All right, with the help of our periodic table, we are now going to just turn this into a nice equation. Then we're going to balance it. So first of all, hydrochloric acid, we know, by now you should know as well, HCl. That's hydrochloric acid. That's done. Plus magnesium oxide, we've done it in the previous one, magnesium oxide. Okay, that gives us magnesium chloride, MgCl2 plus H2O. Remember, it's a chloride, meaning there's going to be two chlorine atoms that's going to be bonding. So let's go. Let's see if this is going to be balanced. So we're working with hydrogen, chlorine, magnesium, oxygen. Can I find it here? Yes, hydrogen that side, chlorine, magnesium, oxygen. How many do I have on each side? How many do I have on each side? So left hand side, hydrogen, I've got 1. Chlorine, I've got 1. Magnesium, I've got 1. Oxygen, I've got 1. This side, hydrogen, I've got 2. Chlorine, I've got 2. Magnesium, I've got 1. Oxygen, I've got 1. Oxygen in this case, no stress. That's not an issue. However, we are now going to have to look and see. Hydrogen, in order for us to get it to 2, 1 times 2, and I have to put the coefficient there. That is going to make this 2. Chlorine, it's got the 2. That's 2. This side, chlorine is 2. So far, we're looking at it being balanced. 2 HCl. Magnesium is 1. Magnesium is 1. Oxygen is 1. Oxygen is 1. Do you guys see that we've only had to put a coefficient of 2 in front of the HCl plus MgO gives me MgCl2 plus H2O. Right guys, I think I am going to call that lesson number 2 for balancing chemical equations. I hope you enjoyed this lesson or you understood it a little bit better. Please send me a message in the comments of this video if you want me to describe something a little bit better. But if you really would like to help the channel out, please subscribe, tell your friends about the channel, and as always, give me a thumbs up. I'll see you guys in the next video. Bye bye for now.